So this is the last section of the last chapter of Math 110, section 7-7. I know some of y'all are singing the Hallelujah chorus, but others might be really depressed. So if you're one of those depressed ones, remember you have lots of YouTube videos so you can go back and watch these over and over again whenever you get sad about not being in a math class. Well, let's get started. So we're going to do systems of inequalities. So I'm going to start just by reminding you how to graph lines. We've done that in this chapter, but I'm going to show you, I call it the shortcut. You've seen this shortcut before, but you may have forgotten about it. So instead of solving this thing for y, we're going to use x and y intercepts. So when you graph using lines using x and y intercepts, you're going to plug in some zeros. So to get the x-intercept, all I want to do is have my x there. So I'm going to put a 0 right there for my y. So that just gives me 3x equals 12. So my x-intercept is going to be -4. So I'm going to go ahead and put that dot on my graph. Okay. To do the y-intercept, then instead of letting the y be 0, you're going to let the x be 0, so that makes that disappear. So all I have is my y. So my y is going to be 3. And then I just connect those two dots with a line, and I've got my line. So that's I call it sort of a shortcut to graph lines. Now, we're not graphing lines, though. We're graphing inequalities. So with inequalities, you've got two questions you've got to ask, okay? The first is my line actually going to be, or is my graph actually going to be a solid, or is it going to be dashed? Well, look at the one that we just did. This one had an equal to mark, right? Had an equal mark. So it was a solid line. So the same thing applies here. If it has an equal mark, then it's going to be a solid graph. If it does not have an equal mark, then it's going to be dashed. Okay? And then the next thing you do with inequalities is you have to shade. So you're going to pick a point and determine if you shade where the point is or not. So best way to do that is just to work a problem. So let's graph this one. Again, I'm going to use my little shortcut. If I do my x-intercepts, I'll put a 0 in for my y, so I'll just get my x as 2. For my y-intercepts, then I'm going to put a 0 in for my x, so I wind up with negative y is 2, so my y would be -2. So I've got my dots. I've just got to determine if it's a solid line or not. Notice it has that equal mark there, so I know it's going to be solid. So then I got to shade. So I can pick any point. I can pick any point over on the top or the bottom. I can't pick a point that's on the graph, but top or bottom, either one. The easiest I find is 0, 0. So I'm going to plug in a 0 here and a 0 there. 0, 0 is my point. I guess I should put it down there. 0, 0. So I'm going to put 0 minus 0 is greater than 2. So is that true? Is 0 greater than or equal to 2? Nope. So that means I'm not going to shade over there. Okay? If it's not true, I don't shade over there. I'm going to shade on the other side. So that means any point in the shaded region or on that line, if you plug it into this equation, you're going to get something greater than or equal to 2. So now let's do the second example. Notice this example is no longer a line. It is it's got a squared, right? It's got a squared right there. So that means we know what squareds look like. They're U's, right? They're quadratics. So this one has a +2 in front. So that means it's going to open up because it's a plus. The 2 means it's going to be vertically stretched, right? We're going to stretch it out a little bit. Vertically stretched. We also know that this -1 is going to move it down. The parent function would move down 1. The +3 in the middle means I would move it, instead of going to the right, because that's opposite of what we think, it's going to go to the left 3. So my vertex is actually going to be at -3, 1. Down 1, left 3. and I know it's going to open up. Now, I'm not just going to draw something, okay? I'm going to actually calculate what this graph is going to look like, okay? So I'm just going to plug in some points. So my vertex was -1, -3, -1. So why don't I stick a -2 in there? So if I put a -2 in there, I'm going to get 2, let's see, what's that going to give me? 2 minus 1? 2 minus 1, so that's just going to give me 1. So I would have that. I'm going to do one more. Let's plug in -1. So if I put in a -1 there, let's see what I get. Let's see, 2 times 4 minus, it's going to give me 7. So 1, 2, 3, 4, 5, 6, 7. So I'd have a dot there, dot there. Okay, so I need to graph it. I need to look at the inequality. Notice it does not have an equal mark. So since it doesn't have an equal mark, it's going to be dashed, right? It's not going to be solid. It's going to be dashed, okay? And now I'm going to pick a point. Again, I love picking 0, 0. To me, it's the easiest. If I put a 0 here and a 0 here, let's see what I get. I'm going to get 0 is less than 2 times, let's see, 2 times 3 squared minus 1. So that's 2 times 9. So 0 is less than 18 minus 17. 0 is smaller than 17. So is 0 smaller than 17? It is. So that means I am going to shade where that dot is. So I'm going to shade outside of my parabola. If I had gotten a no, then I would shade inside my parabola. So basically, any point in this area, okay, is going to be less, is going to make this thing true, okay? So now we know how to graph one of these. Now we're going to graph more than one. So we're going to, remember when you do systems of equations, you would graph the 2 lines, usually they were lines, 2 lines and see where they cross. So basically we're going to do the same thing. To solve a system of inequalities, you're going to graph 2 inequalities and see where they cross. Okay, so couple things. Be sure that you solve it for y. Okay, solve it for y if you haven't, if it's not already solved for y. Graph each equation, and don't forget to shade. Lots of people forget the shading. All right, so it looks like we have 2 lines in that first one because we have no squares or anything. So I'm going to graph this first one. My x-intercept, if I make that y0, the x-intercept is going to be 4. Let's see what my y-intercept would be. Y-intercept, I'm going to, make my x 0. So that's also going to be 4. So I'm going to have a dot 1, 2, 3 here, and 1, 2, 3 here. Notice that this is going to have a equal mark. Okay, so I'm going to have a solid line. Okay, now I'm going to plug in a point. Again, I love plugging in my 0, 0. So if I plug that in, 0 plus 0 is smaller than 4. Is 0 smaller than 4? Yes, it is. So I'm going to shade where that is. So I'm going to shade it down here. All right, so I've done my first one. Now let's do my second one. Let's do it in green. So I'm going to do the same thing. The x-intercept, I'm going to get rid of my y's, so that's just going to be 6. My y-intercept, I'll get rid of my x, so that gives me minus 2y equals 6. So my y is -3. So I would say 1, 2, 3, 4, 5, 6, and -3. Notice that this does not have an equal mark, so that's going to be a dashed line. And then I've got to grab my point again. I love my 0, 0. So I'm going to put 0 in here. 0 minus 0. 0 is bigger than 6. 0 is not bigger than 6. So I'm not going to go in that direction. I'm going to shade on the other side. All right. So here, there's my answer, but it's sort of hard to tell. So I'm going to highlight it. Or maybe I'll just do like this. So it's going to be dashed on this side, solid on that side, and everything in, whoops, sorry, try that again. So that will be my final answer. All right, now notice that was 2 linear equations. Now we've got 2 quadratic equations, so I'm going to have 2 u's, okay? So my first u, notice it's negative, so it's going to open down. So we're going to have, and that basically is our parent function, except it's going to open down. So we've got 0, 0. If I plug in a 1, what am I going to get? Get a negative 1. If I plug in a 2, I get a negative 2. So, whoops, not a negative 2. I get a negative 4, excuse me, because we're squaring. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so notice that one had an equal mark. So I'm going to make it solid. The problem with this one is I can't pick 0, 0 because 0, 0 is on the graph. So I'm going to pick something else. I'm going to pick something easy. 1, 1. It doesn't really matter, again, what you choose. But 1 is less than or equal to negative. Now this is tricky. 1 squared. Notice that I'm only squaring that 1. That stays a negative. So that is saying 1 is less than or equal to negative 1. Is 1 smaller than negative 1? No. So I'm not going to shade it there. So I'm going to shade it inside. So let's shade inside. And now let's do the second one. Okay, so the second one is x squared minus 6. So that is the parent function, and it's moved down 6 places, right? So let's do that one. I'll do that one in green as well. So I'm going to go down 1, 2, 3, 4, 5, 6, and it's going up. So if I plugged in a 1, it would be right there. If I plugged in a 2, it would be 2 squared, which would be 4 from there. 1, 2, 3, 4. 1, 2, 3, 4. You could also just plug in points if you want to. Notice that that is dashed. So I'm going to make it dashed. The good news is I get to use my favorite point, 0, 0, to plug in because that 0, 0 is not actually on the green graph, right? So I'm going to put 0 is greater than 0 squared minus 6. Is 0 bigger than negative 6? It is, so that means I'm going to shade inside. Holy moly, that's hard to see. That means where it's green and blue is my answer. So that's going to be solid, that's going to be dashed, and it's everything in the middle. Now, I know that this is very depressing, but that was our last example. I hope that you have enjoyed learning about systems of inequalities.